Alright, Firestarter 12 is going to go over Firestarter 9, which was something you're supposed to do on your own. Firestarter 10, we went over it in class, so in case you never got that done, it'll be right there. Firestarter 11, that was the last assignment, so I'm going to get 3 assignments done just by looking at this. Remember, every time we do a proof, we are always going to start with statements and reasons. So statements. Remember, this is a formal proof. It has to be legible, so take your time. Make sure you write everything. Free point, make sure you write statements and reasons. Then I'm going to go through and I'm going to do my givens. So given. So I'm going to say FW with a bar is congruent to XW with a bar. Alright. Now the reason for that is given. And I'm actually going to put that in the picture too, because if I have a picture there, I'm going to use it to help me. So I messed up. FW right here, XW right there. Now I'm going to put my second given statement, EW, congruent, not equal sign, make sure it's different, because equals is we're talking about measurement, YW, given. You always put your given stuff first, you don't argue with given information, EW, YW. Right? Now, I told you already that you're going to have to use SAS. So first of all, we're going to start off and say, I know that this is a side statement. I know that's a side statement. So when I look at these, I see side, angle, side, angle, side, angle, side, hypotenuse, which we haven't talked about yet. So, if I didn't tell you ahead of time, side, angle, side, you could look for some sort of reason to say that a third side is congruent to use side, side. But with having the two side statements, it's very unlikely you would use angle, side, angle, or angle, angle, side. So luckily I told you side, angle, side, so I know location matters. I know just by looking at it, it's going to have to be this angle congruent to that angle. I know that because I'm telling you it's side, angle, side. And the congruent angle has to be touching both congruent sides and side, angle, side. What that means is that it literally has to be in between the two congruent sides. So I have my blue side right here, my 1 dash. Then I have right next to it my 1 arc, that's the angle, in between the blue and the green. Alright. So I know without doing any work to make it side, angle, side, the only way that can be true is if I say angle X, W, Y is congruent to angle F, W, E. Right, because that's going to be an angle statement. Now I have to have a reason for that. Luckily, we remember there's something about vertical angles. Vertical angles are always congruent. We learned that. So because we remember vertical angles are congruent, we have a side, an angle, and a side. So even though on my proof it says side, angle, it's the location that matters in the figure, which is why it's okay, it's side, angle, side. So now I'm allowed to say triangle. If you're struggling with how to write your proof, I always just kind of use directions. So like I'm going to start with F, and I'm going to say he's at the corner of 1 dash and no dashes. Then I'm going to go to W. Then I'm going to go to E. So now I went F, then W, then E. Now on the other triangle, I'm going to start at the corner of 1 dash and no dashes is X. So remember it's triangle, X. Then I went from F to W, so W is at the angle at the corner of 1 dash and 2 dashes, so it's going to be W again, and then it's going to be Y. Reason for that, side, angle, side. That's all you got to put, side, angle, side. Now the other thing that we can do, CPCTC lets me fill in the rest of my triangle. So like I could use CPCTC to say this angle across from the 2 dashes is congruent to that angle, or this angle is congruent to that angle. I can also use it to say this side is congruent to this side. So if I didn't tell you a specific thing to prove, you could pick any one of those 3 statements to use CPCTC. But I told you to prove this. So you have to say y, x, w is congruent to angle W, F, E. Let's see if it's true. y x w is congruent to yxw is congruent to w f e. That's true. So the reason for that is CPTC. CPCTC, corresponding parts of congruent triangles are congruent. You also, if I didn't tell you that, you could have said FE is congruent to XY. You could have said angle WEF is congruent to angle XY W. Alright, that's it for Firestarter 9. 10, we did it in class. So remember, we started with statements, reasons. We know we're using angle, side. We know that. Alright? So I have to start with my given. My given states angle. So I'm going to start with my first given. Angle JLK is congruent to angle DFJ. Given. So I'm going to write with all my given stuff down first. So there's one given. Here's another given. LJ. Now remember, that means parallel to FD. That does not mean congruent. That means parallel. Given. And then we have J is the midpoint of KD. Given. Now, this first statement is an angle statement. This one is neither, this one is neither. Whenever we have a neither statement, it should lead to an angle or a side statement. And almost all the time, parallel lines usually, if I could spell usually, lead to congruent angles. Because remember, we have two parallel lines cut by a transversal. I don't know if you guys remember, but we had stuff like that. Alright? So this is my parallel lines. Alright? This would be the transversal. So this would be the green line here. And we know that with parallel lines, we know that alternate interior angles are congruent, which these are not. We also know that corresponding angles are congruent. So I'm going to say this guy is congruent to this guy. I'm going to erase all this other parallel stuff just so nobody gets confused. So from my picture, from my given, I know that angle JLK, so JLK, is congruent to angle DFG. I know that. Now I'm going to use this statement right here. Because they're parallel, I get to say this guy is equal to this guy. So I'm going to say angle FDJ is congruent to angle LJK. And the reason for that is corresponding angles are congruent as long as we have two parallel lines cut by a transversal. So remember, this right here means two parallel lines cut by a transversal. We've used that before. So now I have an angle statement. Sometime in the future I won't tell you what kind of statement you're going to be using, but today I'm telling you you're going to use angle, side, so I know I need to have a side statement. And just for the record, usually midpoint leads to congruent sides. So if I know that J is the midpoint, I know that this guy is congruent to this guy. So I'm going to say that KJ is congruent to DJ, and the reason for that is that's the definition of midpoint. If I know what midpoint means, I know that's specifically in the middle. And now I have a side statement. So I get to say triangle, and I'm going to start with F, and then I'm going to go D, and then I'm going to go J. So I'm going to say F, D, J. Now, I could use my directions. So F is on the corner of no dash and no dash. So that means L is on the corner of no dash and no dash, or they're both one arc angles. And then D is on the corner of one dash and no dash. So that means J is going to be next because it's on the corner. And then we're going to end with K. The reason for that is angle, angle, side. Remember, CPCTC fills in the rest of the triangle. So I could put my third angle here. I could put these two sides are congruent, or these three sides are congruent. This is what it told me to prove. If I didn't tell you what to prove, you could write down any of those three things in black, any of the two side statements, or the angle statement in black. So I'm going to say angle LKJ, LKJ is congruent to angle FJD. The reason for that is CPTCC. So remember, CPCTC will always end the proof. In this type of proof, it will always directly follow angle, angle, side, or side, angle, side, or side, side, side. It can never come before. This always after that. Alright? Alright, last one, Firestarter 11. So we are writing a two-column proof to prove this. So I did not tell you what method to use. You could use any method that you want to use. Alright? So I'm going to say statements and reasons. The keyword is perfect. The keyword is perfect. FW, XW. So I have FW, XW. So FW, XW. Now I'm going to say EW, YW. So I write my first proof. My first statement. Remember, we always start with given. Then my next one, EW, YW, EW, YW. Now, I don't know that I'm going to be using, I could use side, 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 angle, side. I could use any of these right here. Alright? And here's how I think of it when I don't give you any specific information on what triangle theorem to use. So I start off and I look at it and I say, so this last one, HL, always has a 90-degree angle. We'll talk about that later. I don't see a 90-degree angle. There's no way it's that one. Alright? There's no way it's angle, angle, side, or angle, side, angle. Why is that? Because I have two sides. So I have to be able to figure out if I can say an angle is congruent to one another or another side is congruent to another. If I could say XW and FE are congruent, then I would use side, side, side. If I could say this angle is congruent to this angle, I would use side, angle, side. Now, I look at my given. I've used all my given information. So I need more info for sides. The only way you can get a side congruent to a side without any specific given information is reflexive property. And that means FE and XY would have to be part of both triangles at the same time. They're not. They're two separate lines. That's usually when you're looking at, like, it's something congruent to itself. With angles, I know that I could use vertical angles. I don't have to be told that vertical angles are congruent. I could just look at it. I just look at it, the picture. So because I see that, I actually get to say angle XWY is congruent to angle FWE. That's an angle statement. And the reason for that is because vertical angles are congruent. So now I got to look at my picture. Is my side, my angle in between the two? So I see blue. My purple arc is touching the blue and it's touching the green. That means it's in between both. So that means it is in between. So I do get to say triangle, and I'm going to start with X. I'm going to go to Y. I'm going to end with W. So then I use directions on the other one. So X is at the corner of 1 dash and no dash. Y is at the corner of no dash and 2 dashes. So I go to E. So I say F, E, and then I end with W. The reason for that is side, angle, side. Now that I have this, I could fill out the rest. So now I get to say this angle is congruent to this angle, and this angle is congruent to this angle, and I can even say this side is congruent to this side. So anything in black, any black statement on the figure can be written as CPCTC. Can YXW and WFE is that one of those ones? So WFE, YXW looks good to me. So I say CPCTC. And that's it. So if you didn't figure out that this was the exact same problem as Firestarter 9, I just didn't tell you to use side angle side, shame on you. Alright, that's all I got.